Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of the Pythagorean Theorem, specifically how we can apply it in a few different situations, and we'll do it in 5 minutes or less. So we have what looks like a rectangle on the screen, but really all we know it is a parallelogram, which means it's got two sets of parallel sides. How do we prove that parallelogram ABCD is a rectangle? Well, right, we know that if we can say that line BC is 5 and it's a parallelogram, we can say that AD is 5. Same with the two bases, right? If DC is 12, then AB is also going to be 12. But that still doesn't help us prove that it's a rectangle, because a rectangle is a parallelogram with four right angles. So let's prove that that is a right angle. And how can we do that? Well, with the Pythagorean theorem. So a statement that we could write would be this. We could say that BC squared plus, and let's just do it in letter order there, CD squared equals BD squared, right? That is our Pythagorean theorem. A squared plus B squared equals C squared. Now, if we were to write this, we would, instead of saying the BC and the CD, we would actually probably replace that with the values, right? So we would say 5 squared plus CD is 12 squared, and that would equal BD squared. And unless we got a ruler, unless they give it to us, right, we wouldn't be able to necessarily say that, but this would be a proof. And if this was a real triangle, we'd get out a ruler and we see, oh, that BD is 13, and then everything would be good to go, because that's what it is. And so we've proved it's a rectangle. Sometimes they give you just a basic right triangle, and you have the hypotenuse in one of the legs. You're needing to find the other leg. So let's write this down here, right? A squared plus B squared equals C squared. So we're going to call this A, we're going to call this B, we're going to call this C, and we're going to solve for B. So we can say 10 squared plus B squared equals that C squared, that's going to be 26 squared. Well, I know that 10 squared is 100. 26 squared is 676 plus B squared equals 676. So I need to subtract 100 from both sides to isolate that B squared. So B squared equals 576. So now I simply need to take the square root of both, and I would get that B equals 24. That's another way that we can apply the Pythagorean theorem. And sometimes they give us a word problem, and they don't even give us a picture. So, can a triangle with the following side lengths be a right triangle? Right, so let's just draw an example here, just so we have a visual reference. And we should know, right, that our hypotenuse is always going to be our longest one. So it doesn't really matter what the other two are. So let's just label this as the 8 meters, the 15 meters, and the 17 meters. Can this be a right triangle? Well, you know what we're going to need to use? We're going to need to use the Pythagorean theorem. So we're going to say A squared plus B squared equals C squared. Let's just go ahead and label these for us. A, that's B, and that's C. All right, so I've got my 8 squared plus 15 squared equals 17 squared. Let's see. Well, my 8 squared, right, most of us know that. That's going to be 64. What's my 15 squared? That's 225. And then my 17 squared, definitely need the calculator on that. It's 289. So my question is does 64 plus 225 make 289? The answer is yes. 64 plus 225 does make 289. So you can use the Pythagorean theorem to prove a right triangle even without a picture if just given the three side lengths.